We were just looking at examples of limits as x goes to infinity and negative infinity and solving those. We were also talking about in this section vertical asymptotes. So we want to know what's happening at a vertical asymptote as we approach that vertical asymptote on the left, and what happens when we approach that vertical asymptote on the right. Is that value on our graph shooting upwards or downwards? And so recall, we had an asymptote, vertical asymptote at x equals a, and we looked at the limit maybe as x approaches a on the left-hand side of a, so that negative, what looks like an exponent of f of x. We want to know, is that graph going to be going up to positive infinity? Or if we looked at that limit as x approaches a on the left of f of x, we want to know, does it go down to negative infinity? So instead of going upwards like this, it would be somehow shooting downwards, going to negative infinity. So same sort of idea. We want to see if we're coming in on the right-hand side of that vertical asymptote, is our graph shooting upwards, or is it shooting downwards? And so mathematically, we would write it as limit as x approaches a on the right-hand side, so that plus f of x. We want to know, is it equal to positive infinity or x approaches a on the left and right? Oops, that was both left. Sorry, that was right up there. Is it going to negative infinity? Okay, so we want to know which way is it going. That will give us more of an idea of what the graph is going to look like. So let's look at an example. And let's look at, if we were looking at the limit as x is approaching 0 from the right-hand side of 5 over 2x. So recall, we can tell where vertical asymptotes exist if we have a rational function. We do 5 over 2x. If there is a value which sets our denominator equals 0, but not also our numerator. And so notice that here, if we plug in 0, where we see an x here, that sets our denominator equals 0 and not our numerator. So this is an example where if we did direct substitution, we would get 5 over 0. If you get something like this, a lot of times we just say, this does not exist. But we want to know what's going on as we're coming in from the right-hand side. So again, are we going to be shooting upwards or were we going to be shooting downwards? So this is where you kind of just think again about logic. And when you plug in a number on what side of 0 in this case, if I plug in a number on the right-hand side of 0, notice that those values of x are going to be positive. So in this case, my x values are greater than 0 when I plug them in here. And so if I think about that, well, 5 all over 2 times a positive number, this is going to equal a positive number. And so since that's a positive number, I know that then as we're coming in on the right-hand side, this has to be shooting upwards to positive infinity. And so in this section, they're asking us which direction, and we want to say this is equal to positive infinity. We notice if we were looking at the other side of that vertical asymptote, and we looked at the limit as x is approaching 0 on the left-hand side of 5 all over 2x. Notice when we plug in values in here to the left of 0, these are values when you're plugging in a negative number close to 0. And so I noticed that when we do this, we would get 5 all over 2 times some negative number. Well, 5 over a negative number is equal to a negative number. And so because of that, as I'm approaching 0 on the left, this is going down to negative infinity. Let's just kind of pull in a little more of what we've learned. Notice as we go off to positive infinity. So if the limit as x is going to positive infinity of this 5 over 2x, well, this is equal to 5 over some huge number, infinity. But remember, a number over infinity, that goes to 0. So we have this horizontal asymptote here at 0. Okay, so it's going to be getting closer and closer to 0 as x goes to positive infinity. Same idea, looking at the limit as x is going to negative infinity of 5 all over 2x. Well, this is 5 over negative infinity, but 5 over something that is getting really, really small. That goes to, but really, really, really big, actually. That goes to 0, opposite value. So we can use these now limits to explain what's happening with vertical and horizontal asymptotes, what's going on our in behavior of our functions.